Okay, so I've been trying to hack my Xbox One. Thought I'd start uploading videos about it. So start with I was watching the video of the guy who the guy who originally hacked it not too long ago. His name is Markus. He did it in a reverse conference, Orlando or whatever. But he had a ton of screenshots and like information in his video. He also had like examples of his work. So I saved those screenshots, or I screenshotted those, each one individually, just to see if I could replicate it myself. Some of them are duplicates though. Okay, and so with that, I also have I can open the tab, an Xbox One Fat Grable retail data sheet, or schematics for how this board is supposed to be put together, which is extremely useful. And I have several different sites open of the data sheets for components that Markus used in his video and for components that are on the board. And so what I've been doing is I've been using a ESP32 as my microcontroller to try this out. And see, here's I'm still like very much working on it. I've been using AI to help me too, so I've been like talking to it for a lot. But right now this is my original code I had. I'm working on a little bit of a revision of it, but it's just this right here. I don't think this code works, so it doesn't do anything that I want it to do yet. It's all, the timing is like way off, but basically I need to be able to. He has kind of a lot of tools to use though. I only have an oscilloscope, a voltmeter, and a soldering iron and some other stuff, but I had to like connect the dots with several photos. Some of the photos were like missing parts that other photos had. So what the goal is to have these postcodes right here. I see, I could probably use a screwdriver to point. These postcodes. So this one, that one got ripped out, which is my bad. That one. I think that's pretty much all of them. The picture shows better, but yeah, here's the picture of the postcodes. They're color coded. That one's a little hard to see though, the blue. I ripped out the first one by accident, pulled a little too hard on the copper wire. So with that, you're supposed to see when you turn on the Xbox the SOC power OK, which is like the indicator that the Xbox is ready to be booted up and stuff. That goes high and stays high. These are postcodes. What I noticed is that they go from high to low, and then like he described in the video, it's all like pre-boot stuff. So normally you won't see any of this unless you glitched it, or not pre-boot. This is like very first boot stuff. And this is like after you get to our hardware level, which is like not really possible to hack, I don't think. So he went with just hacking the very first, like even before the Xbox like enables, to try to glitch it and then get it to turn on the postcodes, so that way you can know that you skipped the security factor. So right now mine, oops, okay. Right now I am able to see this enable. I am able to see the SB init, or interrupt, I mean, enable. I always mix up the INT. I don't have any I2C stuff connected. I don't have post 0 anymore, so I've been using post 1. And I've been able to see that when I turn on the Xbox, or even when I just plug it in, this guy goes up. This guy is a little different from what my Xbox shows. But instead of the postcodes starting up and going down right when it's plugged in, or right when it starts booting or checking the background, it'll pause. Like I plug it in, takes a little bit. This guy goes up. I plug it in. These guys are still off and go up a little bit before. Sometimes or these guys don't go up at all actually. So as soon as this guy goes up, it goes up, and then later I'll see the postcodes enable for the second stage, and so I don't see it go down or go up when I first plugged in at all. So I don't know what to do about that, and this guy's way different than what it is in the screen shot. And so next thing I've been trying to do is figure out like where he's getting this MB core signal that he's able to fine tune and find a part of it where it drops, and then it has like the boot ROM execution and the noise from that. So this is where I thought it was, or let's see, because he has a, no, not there. See, I'm pretty sure he was reading it from like somewhere like right where this guy was. But then if I look in the video or the board, he doesn't have that there for the board he hacked. Was able to hack. So, see, even this board in this photo, this has it, but that's not the board he showed or presented that he hacked. That was just one of the ways he was measuring things on it. So I really don't know where to continue from this, but basically I can show you guys what happens when I turn on the Xbox. So I actually have some points soldered to like points on here where I can measure certain attributes. So the MB power, or MB, I think, yeah, MB Corel. See if I zoom in a little. Oh, what the MB Corel is this guy, where it gives the example of it. So if I go up here, if I copy that, Control C, no, it's Control X, Control C. Then I paste that into search, just to make it a little easier to find things. And then look through all the times it's mentioned in the page. I'm looking for a test point where I can directly connect MB core. And so if I look around, or I actually think that this is the one I have it connected to, is FT4U1. FT4U1 is way on the bottom. Let's see, screwdriver. So FT4. See, I had it somewhere around here. Oh wait, no, that's the wrong place. FT4U1. FT4. Oh, it's on the top, I think. No, it's right here. Yeah. So FT4U1. This guy right here. So I can measure this guy. In fact, I'm gonna hook it up just so you guys can see. So. In fact, I should probably desolder something though. Well, actually, no, it doesn't matter. I'm just gonna. No, I'll just connect it up. So, connecting up the channel 1 on my oscilloscope, which is yellow. And connect this guy. Let's connect up ground to ground plane, which I have this transistor connected to right here. And then I have this guy right here. So I'm going to connect it right at the very edge of that where I get to focus focus on it. On the very edge, right where I have solder. Where I've soldered it. To the very edge. Okay. And nothing's doing anything because my Xbox isn't plugged in. So, if I go back. Oh, and yeah, let's connect up the postcode so you guys can see what I'm talking about. So I can connect the purple line, which is channel 2 on my oscilloscope. Connect negative. Let's see, where's my postcode? I have this postcode, this guy right here. Just going off the side. That's the wrong guy. Okay. Okay, I connect it to postcode 1, or postcode 0, but postcode 1. Okay, so now you see the oscilloscope. You set it, I have it on roll mode just so you can see it roll out as it goes. I'm gonna scoot that in a little bit. And so, if I look back at the way it should come out for my Xbox, or for this model, which mine is the 2013, exactly, like, not exactly, but like a couple days after or something, I'm not sure. But this one, the stock power, or the MB core, wait, do I not have that? Because MB core should, yeah, the MB core should go high, should be high. No, huh? Let me just do some stuff real fast. I think I might have connected the wrong guy. No, yeah, let's connect that to stock power. Okay. So instead of MB core, that was kind of necessary. You know, look for, go back to top. Maybe I can just search it right here. SUC or SOC, stock power. Stock, I think it's underscore PAL. Power, maybe? Nope. See, stock, PAL. Yeah, that's more like, okay, PAL, okay. Yeah. Power, underscore, okay. I'm gonna search for this guy, see what test points it has. Let's see, it looks like it's on FT5R1. I think I already have that hooked up right here. FT11, nope. FT5, because the board has like kind of a nice label. So it's gonna be on T5. So FT or T5 should be right around. Oh yeah, right here. So FT5R1. So if we take this guy and actually connect up this guy instead of MB power or MB core. Just connect this guy. Okay. Drop this guy instead. Now guys, connect to channel 1. Just make sure nothing's cracking off though. I don't want these wires to short out anything when they shouldn't be. This guy. Okay, because that would not be good if we short when we're not wanting one. Okay, so now go back to a screenshot. Mine is supposed to zoom in on this. Mine is supposed to, so the power, okay, is supposed to enable. Then if we look at the milliseconds up here, around like 430 milliseconds. I tried to calculate as close as I can. It's like probably off by a little bit. Right around 430 milliseconds. So if we go 1, 2, 3, 4, no, maybe 420. Right around 420 milliseconds after startup. I don't know if it's mill or no, it's mill. Yeah, it should, the postcode should do the same sequence. So if I go ahead and just plug it in, put the power cord in, you'll see right when I plug it in, it's plugged in. So my phone's still like this. Okay, should pop up. I'm gonna pause the oscilloscope right when I see the postcodes come up. Wait, something's off. Huh. Okay. Should we try that? I don't think I had it connected all the way. I wouldn't be surprised. Yeah, no, it wasn't in all the way. It's because only part of the wire is soldered in. Okay. Let's try this again. Let's start this. Oh, I should probably turn this to 2 volts just so it's not as big of a line. Okay. Plug it in. This is like as soon as I plug in, it's not even powering on anything. Yeah, see, look at that. Okay, let it roll through, then pause. Okay, just gonna unplug the Xbox, idling, get that out of the way. If I actually position the whole sensor right when the power OK signal comes, and zoom in on that time-wise, just gonna make sure I line it up pretty much as good as we want it to be, just so it's not off by too much. You zoom out till we just see that the first postcodes. So you see here the stock power turns on, but then before that the postcodes are supposed to be high. But even zooming out, by the time I plugged in my Xbox, or like somewhere over here, and then by the time it started, the power or the stock power turned on, there's no drop in postcode. Like even if I disable this line, it's just always off before then. So if I measure the distance between this and the first SP2 postcodes, it is about, and it's also shorter, it's about like 338 milliseconds roughly. So yeah, something's a little different from mine compared to his. I don't know if it's the way he has it wired up or if he has signals reversed for some reason. Huh. That wouldn't make any sense. Well, so I'm trying to figure this out. I eventually just stopped caring too much about the postcodes and decided to rely on the signal from the stock power, because if that's right before or if that happens like just seconds, I think it's like seconds before the GPIO drops to ground. I think I have it zoomed in, yeah. So, or not seconds, milliseconds. So Efuse reads what's his target before the GPIO dropped to ground. So the stock power OK is like, let's see, see if we can get this right. 1, 2. It's about like, maybe like, wait, if this is half, that would be 1, 2. It's like 1.5. Like 1.5 microseconds between stock power turns on and then the GPIO drops low, and that probably varies by millisecond or not milliseconds before it drops low. Microseconds will probably vary a little bit by that. And so what I'm trying to figure out is if I can just use. See, he was going to use this, but then that's law of jitter and law of difference in microseconds between the time he checks the glitch or the fault. So he has a Efuse reads right here, but Yeah, so mine, when I try to read Efuse reads, I spent like forever trying to figure out where he's reading that from. And I believe it's just from, not that, he's getting it from, yeah, here we go. He's getting it from a voltage comparator connected up to a little part he spliced. So, and put a shunt resistor between. So he has this part he put a shunt resistor between. The voltage converter, I have a more clear image up here somewhere. Just because. And so this, I actually looked up the part number of this. And this guy's output from the op amp. This guy is is 3 volts input. This guy down here is negative to the op amp. This guy's positive to op amp, and this guy's negative to the power of the chip. And this guy's just probably just to measure the signal coming out, and this guy's a signal after the op amp, so like just to increase the power of the signal. And what I notice is that from his, it only spikes, up, but I have my op amp connected. If I measure what comes after it, which would be the same thing that comes, it's probably the same thing he's reading here, because that's what I said connected it to. If I grab this, connect to the purple line, which is channel 2 on my oscilloscope. Just a sec. You connect to the purple line, then reset this, make it roll a little slower so we can catch it more easier. Then plug it in. See, it pops up, but oh, I probably didn't catch it, but I believe that this guy's supposed to pop up too. But it, instead of like, let's see, I don't know if I actually had it caught. Okay, let's try that again. Okay, now try this again. Put this guy in. Boom, it's plugged in. It should both rise. Yeah, so the Efuse read comes before the sock power, okay. Which is super interesting, because I don't know. For him, it's down. It's always down until it hits that little spike, and it's even down before the sock power, okay, turns on. And it's always the same thing with my oscilloscope or my Xbox. Even if I wait until the power turns off again without turning it on, like after I plug it in, if I wait until it turns until Xbox stops doing like its standby check, the power will drop after a bit of being plugged in without being turned on. But once I turn it on again, it does the same exact thing as if it were just to be plugged in again. Which is interesting for a sock power, okay, because that guy, I don't know if it probably isn't the one that keeps it on standby, because there's a couple different standby rails. But if I take this out, zoom this out a little bit, just so we can see the line. So sock power okay turns on 500 or 58 milliseconds after the signal from the Efuse reads. I don't even know if I'm reading it right. Like, I tried finding the Efuse reads on the dash sheet, but where he has it connected up is like really. I tried to find it, but it was like it was in between a ton of different things. It was kind of next to Efuse reads, but kind of like in between some stuff, which is probably why you put the resistor there and had it like op amped up a little bit. But yeah, that's where I'm stuck at now. I'm trying to figure out if I should just, because what I was doing before, I was just trying to glitch it randomly, or not randomly. I still had like a timeline, but I was trying to glitch it just before the sock power, or it's just after sock power, okay. Or yeah, because let's see, what do I have this connected to? No, I was glitching it based off the power button, because if I let the Xbox sit, I can just press this power button, it will dip in voltage, this guy will see that dip, and like I have it set to a couple milliseconds after, because that this button has a lot of time between it and when the Xbox literally enables sock power. Okay, and then I have it to output on this transistor, which will short this rail to ground, which is supposed to be, which is also, I think that's NB. No, I don't know what core or what rail. I probably forgot what rail it's supposed to be shorted when you do the glitch. But yeah, that's where I'm stuck at now. So I guess this concludes part 1. I'll update you guys with any further information I get.